What is up, chemistry? Chemistry, we are going to do stoichiometry. This is our first notes of the distance learning here. And what I want you to do now is to try your best to think about what I'm talking about here and follow along. This is some new stuff, but we're basically adding on to what we've already learned before about balancing equations and doing unit conversions. Okay, so what do we already know? Well, we already know how to do numbers of atoms or number of molecules to moles, right? Well, to do that, we just make that 6.022 times 10 to the 23rd equals 1 mole. And we use that as a ratio. These are ratios that we use to help convert atoms to molecules. So remember I had asked you how many moles of sodium are in 35 grams of sodium. So you would use the molar mass and things like that. And then that's the same thing you did here. Molar mass equals 1 mole. So you use your molar mass to figure that out. Now, we haven't done this at all. Don't worry about this. If you go into AP chemistry or take any type of nursing, any type of STEM majors, you will end up learning about gas and things like that. We ran out of time this year. That's too bad. But you'll figure it out another time. Or if you want me to go over it in more detail, I can talk to you about it personally. Stoichiometry is calculating quantities using the chemical equation. So basically, this is building up to what we've been doing this entire time is trying to use our chemical equations, okay? And if you know the amount of one substance that you have, for example, if you know how much material is on one side of an equation, you can use stoichiometry to figure out what's on the other side of the equation. That's the beauty of it. So having a chemical equation allows you to be able to calculate information from it. With some basic information to start with. Okay, so let's look at this first one. This is something we've done before. We've taken this as a combustion reaction, looking at this carbon here. Now we easily can balance that. I'm not going to show you how to balance it. I've talked about it many times, but now that we have a balanced equation, we can basically figure out some more information from it. Okay, so they can give information about how much particles there are on either side. That's what these coefficients actually do. Okay, they actually tell us how many particles. Okay, so for example, 1 molecule of C3H8 plus 5 molecules of O2 turns into 3 molecules of CO2 and 4 molecules of H2O. Okay, same goes for moles. We get 1 mole, 5 moles, 3 moles, 4 moles. So it just shows us, like with conservation of mass, how many moles we have. Okay, so let's look at some coefficients. So basically, if we want to look at the ratio of different things, we can actually use these ratios in our dimensional analysis. Okay, so you can say this is equal. So here we've got C3H8 right here. 1 mole of that is equal to 5 moles of this in your equation. What's the ratio to this? Well, we have 5 moles of O2 for every mole of this. So we can use this as another equality, another part of our dimensional analysis. Okay, so let's do a problem together, and you'll see how it looks like. Okay, so calculate the number of moles of oxygen required to react with exactly 4.3 moles of propane in a combustion reaction. Well, we're going to start with 4.3 moles. Okay, let's write the balanced equation. We already have the equation. Okay, now let's use the mole ratio to solve. Okay, well, the mole ratio is that there are, says here that we have 5 moles of oxygen in this reaction for every 1 mole of C3H8. Okay, so what we do is we put our number that we have, okay, and we multiply it by our mole ratio. Okay, we want to cancel out each one of the parts. Okay, notice here we canceled out the moles of C3H8 and we multiplied across to get the total moles. Okay, very similar to changing our units. Okay, let's check another one out here. Okay, yeah, you gotta have those units in there. Write the equation for the decomposition of water. Decomposition of water is the breaking down of water. Okay, so we need to write the balanced equation first. Okay, here it is. 2H2O makes 2H2 plus O2. Okay, there's our mole ratios at the bottom. Okay, so we're going to use for our equation here. If you're given 5.8 moles of water, what are we going to do? Well, if we have 5.8 moles of water, we're going to use this right here. Okay, because we want to get hydrogen, first, and then we want to get oxygen next. See how that works? We're using the mole ratio of hydrogen to water, and we're using the mole ratio of oxygen to water. Okay? That's the moles. Okay, so that's the beginning of that. I want you to practice thinking about that for a second, and once you kind of take a look at that, I want you to go on to the next video. All right. See you in the next video. Bye.